David Smith here with another Flipped Classroom math video. A few tips before we get started. Remember, you can always pause the video to make extra notes or write down questions for when we meet in class. Also, remember to pause the video when I provide an example. Work that problem, then start the video up again and see how well you did. You can also turn on the captions so you can see my words written below on the screen. You can also speed up or slow down the video if you wish. Remember to think hard, follow along, and bring your best brain to the next time we have class. Today's topic, graphs of quadratic functions. Remember, functions, we used to call them equations. We just have some new vocabulary. We're calling them functions now. The key to understanding these graphs is to know backwards and forwards the basic one, which is just f of x equals x squared. This is the simplest quadratic function. What shapes do these graphs make? They make parabolas. Okay, so in this section, we're going to just make lots of different parabola graphs. Okay? You're going to get really good at it, I promise. Okay, so here's our basic function. All we do is we square whatever x is, and that gives us y, like a one step. I recommend you make a table of values. For this function, I know that these values for the x are going to be good. They're going to show what the graph does. As you get better at this, you're going to pick different numbers to plug into your function depending on what your function looks like. Okay, so this is the basic function. -2, -1, 0, 1, 2 are the perfect numbers to pick so that when you graph it, it shows you what that parabola is doing. Okay, so let's go through this. When x is -2, x squared, -2 squared becomes +4, so f of x is 4. When x is -1, -1 squared is 1, 0 squared is just 0, 1 squared is 1, and 2 squared is 4. So you'll notice that on in the f of x column, it's going to start going, it's decreasing, it went to 0, and now it's increasing again. You're going to see this kind of relationship every time you graph a parabola. It doesn't always turn at 0, and that's the tricky point for picking your x values. We'll do more on that in a minute. Okay, so I have my table of values. What this basically just says is that when x is -2, f of x is 4. When x is 0, f of x is 0, and so on. So now I can put that on the graph. Notice my range in values. I don't have anything bigger than 4, okay? And I don't have anything for the x smaller than -2 or bigger than 2. So I want to take that information when I put my tick marks on my graph. So I made 4 tick marks because I don't need to go any bigger than 4. Okay? So let's do my first point. -2, 4. So that's -2 up 4. It's right there. My second point is -1, 1. So that's right there. Then I have 0, 0. Then I have 1, 1, and 2, 4. 1, 1, and 2, 4. Okay? So now I can see what the shape is going to be. I want you to do your best job drawing this nice parabola curve. It needs to go through all the points. It needs to turn at this special point right there. We're going to learn more about that later. So here we go. Not too bad. Put arrows on the end to show that this thing just goes forever, because we could just pick really big numbers or really small numbers for x and we'd get a value for y. Okay? So a couple things to notice about this graph, because you're going to need to exploit that when you graph more complicated parabolas. The vertex. This is the place where the parabola turns. It's going down, it's decreasing function, and then it turns at 0, 0, and now it's going up. It becomes an increasing function. This point is a minimum. It never gets below here. Okay? So that's a minimum. We have parabolas that open downward, in which case that vertex is a maximum. Notice also that the next point from the vertex is 1 over and 1 up on both sides. 1 over, 1 up. And then the next point is 2 over, 4 up. 2 over, 4 up. That shows really clear in the table of values, okay, with this most basic parabola. Other parabolas will do different things depending on the function, but understanding this one will help you graph those parabolas nice and quick. Okay, let's make a graph of a little bit more complicated parabola. I put the function up here. It's f of x equals 2x squared plus 2. Remember, the other one was just plain x squared. So we're multiplying the value here by 2, and then we're adding 2 to the result. So it's going to give us a little bit of a different graph. Okay, so if I plug negative 2 in for x, negative 2 squared is 4, times 2 is 8, plus 2 is 10. Let's plug negative 1 in. Negative 1 squared is 1, times 2 is 2, plus 2 is 4. 0 makes this whole term go to 0, because 0 squared is still 0, times 2 is still 0, so all we have left is the 2. Notice how our numbers are decreasing. But do you think we've got to the vertex? Are they going to start increasing here? Let's see what happens. I'm going to plug in 1 for x. 1 squared is 1, times 2 is 2, plus 2 is 4. 2 for x. 2 squared is 4, times 2 is 8, plus 2 is 10. Okay, so it looks like our turning point is right here at the 0. Notice how it was decreasing from 10 to 4 to 2, and now it's come up to 4 and to 10. Okay, so now I'm going to use my table of values to put points on my graph. Now, check this out. My y's go all the way up to 10. So what I'm going to do when I scale my axis is do 5, 10. 5, 10. 5, 10. And negative 5, negative 10. Okay? So this is going to make a kind of skinny parabola you're going to see in a sec. So minus 2, positive 10. Minus 2 is probably about there. 10 would put me right about there. Minus 1 is 4. So minus 1 probably about there. 4. What's my 0? It's 2. So 0, 2 is probably right there. And now we're just reflecting, we're just coming back up. Positive 1, 4, positive 2, 10. Just like these were negative, but these values were the same. So what I can do is I can use that fact to just mirror my points across the y-axis. So now I have these 5 points for my parabola. I'm going to carefully draw my curve. Oops, that was a little bit messy. Let's see if I can do that better. Okay? Yeah, close enough. If this was on a test, I'd be fine with that. Here's what I don't like. Parabolas are not V's. They're not V-rabolas. Okay, so don't make it a point. It's got to be a curve. Okay?
If you still have questions, write them down now and bring them to our next class. You can also watch the video again and perfect your notes. Finally, if you enjoyed watching my video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.